All right, to review scale factor and dilations, we need to remember that the scale factor is a fraction made up of the new over the original. And the new is going to be the rectangle ABCD prime in this problem, and the original is just ABCD. So we want to know which best represents the change in the vertices of rectangle ABCD to form rectangle ABCD prime. So we can look and see, we can count the side lengths. This is 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can set my fraction up using the side lengths. The new one with the primes is 9 over the original, which is 3, and 9 divided by 3 is 3. Or I can use some ordered pairs. For A, my x is 2. That's my original. And for A prime, my x is 6. So I can use 6 over 2, and I also get 3. So whether you count the sides or use a point, you're going to get a scale factor of 3. So the one that represents this would be h, because we're multiplying both our x and our y by 3. All right, to work the next example, which dilation centered at the origin would create the line segment xy prime at these endpoints? Well, in 8th grade, they're all centered around the origin, so you don't really have to worry about that part. And we're looking at xy right here. And right now, x is located at 8 and 3, and y is located at 8 and negative 4. So I want them to change. I want them to, when they're the prime, the new one, be at these locations. So I just need to figure out which of these am I multiplying by. Well, since it's going to get larger, it's going to increase. It can't be this half, because that would make it smaller. So I'm just going to guess and check. I'm going to take each point. So here is A, and I'll multiply it by 1.5, and I get 12, which is what I want to get. And if I take 3 times 1.5, I get 4.5. So 1.5 is going to work, but let me just show you some of the wrong ones. If I do 8 times 2.5, I would get 20. That's not the point I need. And if I did 8 times 3.5, I'm going to get 28. That's not what I need. The one that gives me what I need is B. I have a scale factor of 1.5 to get from these points to these points.